First, let's do a quick review on the lecture 2. In lecture 2, we talk about the infile input statement for inputting a file into the SAS Studio. And we also talk about the file name, put, and file statement. And we talk about the sort procedure, merge procedure, about how to create a new data set or do some modifications on a certain data set. We also include the conditional statement, which is simply the if else and syntax, and the keep job statement to delete certain variables or to keep some certain ones. Today's topics will be of three parts. The first part is about creating titles and variable labels, where we will use the label and title statements. The second part is about generate descriptive statistics, where we will use the univariate procedure step as well as the means procedure and the frequency procedure. We will also include creating charts and plots, how to create a chart and plot, where we will use the chart procedure step and the plot procedure step. Now we move on to our first part about the lecture, which is about the label statement. The label statement is used to attach an extended label to a certain variable. The syntax for it is that after you type in the label keyword, and we use the variable one to specify the variable, and use the label one to create the new label for that variable. The simple use of label statement goes as followed. We type in the name of the variable and the label given to it. And the label given to it. We give like the time needed to complete the exam after the time variable, the exam score after the score variable, and etc. Here are some notes about the label statement. So if you want the labels to show in the output, you must add the label options in the print procedure statement. The labels can contain up to 225 characters. Any characters are valid for labels. If a label contains single quotes or apostrophes, you have two choices. You can either use single quotes around the entire text and two single quotes in place of the apostrophe, and use double quotes around the entire text and use one single quote inside the text. Label statements are both valid in data steps and procedure steps. If in a data step the label is permanent and can only be changed by a subsequent label statement, if in a procedure step the label is only temporary and is valid only for that certain procedure. Now we will move on to the title statement. Title statement is the title of the output. By default, this title is the set system. To change this title, you have to use the following code. The syntax for title statement is after the title keyword, you just type in the table title content, and you can create several titles followed by title 2, title 3, etc. The use of single notations is the same here as in the label statement. Here are several notes about the title statement. Title statements can appear in both data steps or procedure steps. You can create more than one title per page by numbering the title statement as title 1, title 2, etc. Title statements are permanent unless they are changed by adding subsequent title statements. Changing title n will delete all the titles with a number greater than that number. Here is a simple example about the label and title statement. For our data set, we input three different variables: the name, weight, and height, and we use the label statement to give label name to the variable name, and the weight with pounds to the variable weight, and the height with centimeter to the variable height. And we also created two different titles. The first title is survey data. The second one is from New Jersey. and we can create title 3, 2, etc. Also to know the option non-observations here tells the SAS software not to print out the observations number in the output. Now we will move on to the procedures for descriptive statistics. We will use the univariate procedure, the means procedure, as well as the frequency procedure. The univariate procedure will have the basic syntax as follows. We type in the univariate procedure and use the data keyword to specify the data set. And we have several different options. And we use the bar variables to tell SAS to analyze the variables according to the groups given by the by statement. And we use the VAR statement to tell the SAS software which variables to analyze. The ID statement will print out the IDs for certain records um, in the analysis. By default, SAS will print the following descriptive statistics in the univariate procedure step for every numerical variable. It will print out the moments, basically the means, variance, skewness, kurtosis, for the variables, for the given variables, and the basic statistical measures. And the basic statistical measures about the median, mode, range, IQ, etc. And several location tests, which will include the results of t-test, sign test, or several different tests. It will also include several quantiles and also give out the extreme values, basically the 5 largest and the 5 smallest observations. So here is the syntax for the univariate procedure step. We talk about the by statement, variable statement, ID statement previously. Here are some important options for the univariate procedure step. The normal options will generate several statistics to test for normality and their corresponding p-values for the given variables. The null hypothesis is that the data are normally distributed versus an alternative hypothesis that the data are non-normal, which is simply what you have learned in the previous statistical courses. As a general rule of thumb, if the p-value from this test is less than 5%, then there is enough statistical evidence to conclude that data are not normally distributed. Another important option for the univariate procedure is the plot option. The plot will add a stem and leaf plot, a box plot, and a normal probability plot for the given variables. The stem and leaf plot is for large data sets. This may be replaced by a horizontal bar chart by default. For the box plot, the top and bottom of the box are the 75th and the 25th percentiles, respectively. The median is denoted by a bar, and the mean is denoted by a plus sign. The normal probability plot will include data points that are represented by asterisks, and the plus signs denote a straight line for reference. If the data are normally distributed, the data points should fall along the straight line. So here are some very basic knowledge you should have already learned in the previous courses. Here are the 3 important statements that are used in the univariate procedure step. The VAR statement tells us to provide results for a specific list of variables rather than for all of the variables. The ID or the identifier specifies a variable whose value is printed next to the smallest and the largest observations. This statement makes it easy to identify extreme observations for certain variables. By statement specifies a variable for which every different value defines a subgroup of observations. The data must first be sorted by the same by variable before using the by statement in the univariate procedure. Here is an example code about univariate procedure, which is included in the second video, which I have already uploaded onto YouTube, my personal YouTube channel. Now we move on to the second means procedure step. The means procedure is a good procedure to use when you are only interested in the basic descriptive statistics. It is more concise than the universal procedures. So basically, what is produced in the means procedures will generally also be included in the results of an univariate procedure. The syntax for means, here's a little typo here. You should replace univariate with means, followed by the data keyword to specify the data set and the several options. Also, we have the follow the var statement, which of the same use as in the univariate procedure step. The by keyword is also similar to that in the univariate procedure step. Here are some default settings for the means procedure step. Without any specified options, SAS will provide a 5-value summary, which will include the sample size, minimum value, and the maximum value, the mean, and also the standard deviations. Here are some important options for the means procedure step. The M-means will tell the SAS to print out the number of missing observations for the dataset. The range options basically is the range. The sum is for the sum. VAR is for the variance. The STDERR is for the standard error. And the T is for the T statistics for testing whether the mean is significantly different from 0. And the property will provide the p-value for the previous t-test. The example code is also included in my second video, so remember to click on my second video and also trying to investigate through the example code. Now we move on to the third procedures today. It will be about the frequency procedures, which will generate tables for some categorical data. The frequency procedure is the same as the previous univariate and this procedure, except it will have another table statement, which will tell the SAS software which tables to generate and which tables to include, followed by several options for the table statement. The table statement is very unique to the frequency procedure step, which specifies which tables to create, either by a single variable name or by 2 variable names, separated by the star sign. For this example, the VAR1 here will create a one-way table for the variable called VAR1. The VAR1 times VAR2 tells the SAS to generate a two-way table of variable 1 and variable 2. Here are several important options for the table statement. The chi-square options will compute the chi-square statistics for testing independence or homogeneity in a two-way table. The exact will perform Fisher's exact test for tables larger than 2 ways, 2 times 2, and the NO column will omit the columns percent from the table. The NOCOM will omit the cumulative frequencies from the table, and the no frequency options will omit the cell frequencies from the table. The no percent will omit any percent from the table, and the no row will omit the row percent from the table. So these options is very simple. So here is simple example code about how to create two-way tables. Here we would like to create two-way tables of the grade and the year, and we're trying to output the chi-square test statistics for those for the two-way table, gender times year, and we also have a two-way table of grade variable against a year variable. Now we will move on to our third part about our lecture, which tells you how to generate chart and the plots for a given data set in the SAS software. So the basic syntax for the chart procedure goes as follows. You have to use the data keyword to specify the data set to be analyzed, and use the by variables to specify whether you have to plot the charts according to the variables after the by statement. So always remember to sort your data set according to those variables before you move on to the chart procedure step. The vbar statement will generally create a horizontal plot, which is basically the histogram. The hbar will create a horizontal chart, which is also the rotated histogram. The by statement will produce a separate chart for each of the by groups. The vbar statement will create a vertical bar chart, while hbar creates a horizontal one. Here are some options, important options for both the vbar statement and the hbar statement. The subgroup options with a certain number of variables we have divided the bar into certain parts, which each of them represents a value of a specified variable. The first character of the variable will be used. The type options will be either frequency or percentage, where the chart will contain frequencies if we use the frequency for the type option, and will contain the percentages if we use the PCT for the type options. By default settings of SAS, it will be of frequencies rather than percents. Here is the example code about how to use a vbar and the hbar statement. In the first one, we use the by statement to generate several charts of the grade variable for each of the year. So let's make a quick introduce. So here we will have the first histogram like this. For example, about for example, the first year, like 19 of certain year, and the second one, we'll just put a second chart, a second histogram as followed. However, if we can also achieve this result by using the subgroup statement here, where we'll create only one histogram but separate into different parts. For example, it will be something like this. We have a histogram. We have several huge bars. Each of them is separated with certain quantities. Each of them will represent a certain year in the subgroup after which is identified in the subgroup options. For basically, these two will achieve the same result, but in the first program, it will create several charts of each year, but the second one will create a single histogram, which is divided into several years. So some attention to the difference between these two steps. Try to understand how by statement and subgroups work. You should try to type in those example codes into your own SAS software and see the results. Also, the results is also included in my second video, which I have already uploaded. Now we move on to the final procedures of the day, which is about the plot procedure steps. The basic syntax for it is that it's very similar to the chart procedure. Um, the same data keyword, the same by statement, but we have to use the plot statement to tell the SAS about your plot request. In the synchronous type of plot, we have like a variable y against a variable x. Automatically, the y variable goes to the vertical axis, and the x variable will go to the horizontal one. The default symbols for the points are that character A represents the value of one observation in the dataset. when a point represents values of two observations, the character B appears and so on through the alphabet. The character Z is used for the occurrence of 26 or more observations at the same printing positions. Um, Here are some um, important examples that will be used in the plot request. First one is the most simplest one. It's simply the y plot. It's simply the plot of the y variable against the x variable. The character here, you can type in like plus, minus, star, or whatever. The observations will be plotted using the characters specified here, such as what I have talked about. Another important example is y against x, followed by a certain variable. Then the observations will be plotted using the first character of the value of that variable here. So basically, it will be y against the observations of y against observations against x, where for each of the observations, it will be marked by the value of the variable here. So for here, for these options, we will plot two different plots on separate pages. The first one will be y against x1. The second one will be y against x2. For this statement, we'll also create two different plots which will appear on separate pages. The first one will be x1 against x. Well, the second plot will be y2 against x. Another important example is this one, which is also equivalent to this code, which we will plot three different graphs, three different plots of y against x1, y against x2, and x1 against x2. It will not include all combinations. The others will count. Since we have three variables here, which means we could indeed have 6 different plots, which will be y against x1, y against x2, xy against 1, x1 against x2, x2 against y, x2 against x1. However, it will only include these three. If you would like to plot vice versa, you have to change either the order of those three variables, or you can either type in like different plots. You can either include another x1 against y. After your input, it will include another plot of x1 against y. So you have to pay attention when you are trying to plot three variables, and they also want to use only one single line of code. So another very important example is about the overlay example. Here we want to put two plots together, appear on the same one, and they will also be overlaid. Here we would like to plot y1 against x1, as well as y2 against x2, which is marked with different characters, and we would like to plot them on the same page, which means we have to type in the important overlay options here. So in the output of the SAS software, you would like have a plot like this. We shall have a big one. We shall have two different markers, like for example, we denote by the multiply symbol and the minus symbol. You might have these two, which means the first plot, and those two are from that second plot. But those two are shown together in a simple one. So we can achieve this only by using the overlay options. This is an important example code. Um, The illustration of those examples will be put on my second YouTube video, which you should check later. So here let's do a quick remarks on those 4 different plots. For the first one, we will just plot the course against the final exam. And for the second one, we will also plot the course against final exam. But for each of the observations, it will be marked by its value from the grade variable. For the third plot, we will give an overlay example, which will plot course against final exam and the course against quiz onto the same plot. For the first one, it will be marked by a F. For the second one, it will be marked by a Q. For the third plot, we will use the grouped version, which will plot course against final exam, course against quiz, final exam against quiz, into 3 different pages. We'll have 3 different plots in 3 different pages. The illustration of those codes will be put onto on my second video. Remember to check. Also remember to run this code by yourself to see the results. Here now is all for today's lecture. So if you have further questions, you can stay here. So see you next week. Also remember to check out my YouTube channel for illustrations of those of the codes.
Hi,